Good morning everyone. How are you all? Hope you all are fit and fine. Okay children, happy to see that you are doing your homework and I heard that you are doing your assignments also. Okay, one day you have to submit all the assignments in your school, okay, because it will be considered for your marks. It will be considered for your marks because there is no quarterly exam till now. So sometimes the government will announce some schemes or other things that you consider the marks of the assignment as the exam, like that they will tell. So we are giving you assignments, homeworks and classwork. Regarding that which you are writing correctly, like that only we will give you marks based upon it. Okay. In the previous classes we have shown P block elements. Okay. What are P block elements? In the periodic table, the 13th to 18th group elements are periodic table are called P block elements. Okay. We have seen the electronic configuration, their metallic nature, ionization enthalpy, electronegativity, okay, like that various things we have seen, and we have seen group 13 elements, okay, group 13 elements, that is a boron group, okay. Today we are going to see about group 14 elements, that is a carbon group 14 element, that is a carbon group, okay. In this lesson only 13th group elements and 14th group elements. In the next lesson, unit 3, we will see about group 15 element, okay. Right. Occurrence of carbon, okay. How the carbon is occurred, okay. Carbon is found in the atmosphere, inside the earth's crust and in all living organisms, okay. Carbon is present in fuels like wood, coal, charcoal, coke, petroleum, natural gas, biogas, marsh gas, etc. This carbon is present in compounds like carbonates, hydrogen, okay, in free state. Carbon is found in diamond, okay. Diamond, have you seen diamond? In diamond, in coal, okay, nilakari, that coal, in graphite. What is graphite? In pencil there is one black needle, no, that is made up of graphite. So in all these things there is carbon, okay. Carbon is found in the native form as graphite. You will be asked as question, in which form carbon is found. So carbon is found in the native form as graphite, okay. Coal, crude oil, carbonate rocks such as calcite, magnesite, that contains large quantities of carbon in its combined form with other elements, okay. Silicon occurs as silica, okay. Silica, that is a sand, okay. The sand, kadalman, okay. The sand is silica, okay. Carbon is coal, coke, diamond, okay. Everything is nature dependent, okay. Chemistry is full of nature. Silicate materials and clay are other important sources for silicon. Silicate minerals and clay are other important sources for silicon, okay. How the carbon is occur? Carbon is found in the native form as graphite, coal formed as graphite, okay. Carbon is found as in the form of graphite, coal, crude oil, okay, carbonate rocks such as calcite, magnesite, that contains large quantities of carbon in its combined form with other elements. Silicon occurs as silica. Silicate minerals and clay are other important sources for silicon, okay. Now these are the physical properties of group 14 element. See the picture. Physical properties, okay, group 14 elements such as carbon, silicon, germanium, tin, lead, okay. These are the group 14 elements. Group 14 elements la enala irukku? Carbon, silicon, germanium, tin, lead, okay. And the physical state at 293 Kelvin la irukumbodhu, the carbon and silicon, germanium, tin, lead, everything is in solid form, okay, at 293 Kelvin, okay. And what is the atomic number of carbon? 6. And for silicon 14, for germanium 32, for tin 50, for lead 82. And what are the isotopes of carbon? Carbon has 3 isotopes, 12C, 13C, 14C. And what are the isotopes of silicon? 2 isotopes, 28 and 30. For germanium, that is 73 and 74, and for tin only one isotope, that is 120, and for lead also there is only one isotope, that is 208. Okay. And atomic mass. What is the atomic mass of carbon? 12. Atomic mass of carbon is 12. Silicon is 28. okay, 0.09, germanium 72.63, fortune 118.7, for lead 207. And their electronic configuration, that s orbital, p orbital, d orbital, okay. In orbital state, the electronic configuration of carbon is 2s2, 2p2, and for silicon 3s2, 3p2, helium, neon, argon, krypton, xenon, that are inert gases, okay. It is in inert form. So what is the atomic radius? It is also given, and the density is given, and their melting point, okay, in which point the solid is converted to liquid, okay, and the boiling point, the liquid is converted to solid, solid is converted to gas, okay. The points are given. These are the physical properties of group 14 elements, okay children. Do you understood? Right. Now, what is catenation? Okay, catenation is a process, okay. Catenation is an important 2-mark question, okay. Everyone should go through it, okay. What is catenation? Let me tell you. The tendency of formation of long chain or open chain, okay, closed chain, open chain, by the combination of same atoms in themselves, okay. Combination of same atoms in themselves is known as catenation. What is catenation? The tendency of formation of long chain, that may be open chain or it may be closed chain, by the combination of same atoms in themselves is called catenation, okay. Ability of an atom to form chain, ability of atom to form a chain. See the fifth point, that is C with double bonding C and C with triple bonding C. In this way they will form a long chain, that is the formation of catenation, okay. In catenation it has some 4 important conditions, okay. Only 4 important conditions, that is, first one is the valency of element, that is element, the valency means the last shell irukkudiya valency, the valency of element is greater than or equal to 2, okay, greater than or equal to 2, that is the first point. And second, the element should have an ability to bond with itself, okay. Element should have the ability to bond with itself. So carbon is bonding with carbon itself, okay. And third, the self bond must be as strong as it bond with other element. So the self bond should be very strong, self bond should be very strong as its bond with other elements. And kinetic inertness of catenated compounds towards other molecules, okay. Kinetic inertness of catenated compound towards other molecules. Further, carbon possesses all the above properties and forms a wide range of compounds with itself and with other elements such as hydrogen, oxygen, nitrogen and halogen, okay. This catenation is maximum in carbon and decreases down the group, okay. Catenation mainly in carbon, okay. This is due to high bond energy. In carbon there is a high bond energy, so only carbon atoms form double or triple bond, okay. P pi multiple bond with itself, okay. It will bond double bond and triple bond as given in the picture. C double bond C and C triple bond C also. Carbon forms double or triple bond with itself, that is called the catenation. The tendency of formation of long chain, that may be open or closed, by the combination of same atoms in themselves, okay. Same atoms in themselves is called catenation. And what are the allotropes of carbon? What are the allotropes of carbon? Okay, let me tell, there are many allotropic forms, that is graphite form la irukku. What is allotropes means, carbon எந்த ஃபார்ம்லலாம் இருக்குது, okay, it is in graphite form, okay. graphiteையும் கார்பன் தான் சொல்லும். So graphite ஃபார்ம்ல இருக்கு, diamond ஃபார்ம்ல இருக்கு, fullerene, okay, fullereneங்கிற ஒரு ஃபார்ம்ல இருக்கு, nano tubes அப்படிங்கிற ஃபார்ம்ல இருக்கு, and grapheneங்கிற ஃபார்ம்ல இருக்கு, ஓகேவா. So carbon is in many forms, so that is called the allotropes of carbon. First of all, we are going to see about graphite. We are going to see about graphite, okay. Graphene, what is graphite came from the word graphene. Graphene means to write or draw, so it is used in pencils, okay. Graphite, I already told you that graphite is used in pencils for writing. So graphite meaning graphene, that is to draw or write. So graphite is used in pencils, okay. Unlike diamond, okay, it is not like diamond, it is a good electrical conductor. So graphite is a good electrical conductor, okay. Now the most stable form of carbon, this graphite is the most stable form of carbon, and the graphite powder is used as a dry lubricant, okay, for the purpose of lubrication graphite powder is used, okay. A single layer of graphite is called graphene, okay. The overall is called graphite, a single layer is called graphene, okay. Carbon exists in many allotrophic forms, okay. Graphite, diamond are the most common allotrophs, okay. So other important allotrophs are graphene, fullerene and carbon nanotubes, I already told you, okay. What is graphite? Graphite is the most stable allotropic forms of carbon at normal temperature and normal pressure. So it is soft, it is very soft, okay. Have you touched the graphite? It is very soft, isn't it? So it is very soft and it conducts electricity. So graphite conducts electricity, okay. It is composed of two flat, two-dimensional sheets of carbon atoms. See in the picture, okay. The ரவுண்டாக இருக்குதா, சின்ன சின்ன ஆட்டம் மாதிரி, அது எல்லாமே கார்பன், ஓகே. ஆரஞ்சு கலரில் இருக்குது, எல்லோ கலரில் இருக்கிறது அண்ட் த கிரே கலர், ஓகே. அது எல்லாமே என்னது ஆட்டம்ஸ், ஓகே. தட் இஸ் அ கார்பன் ஆட்டம். கார்பன் என்ன ஆகுது, எல்லாமே ஒவ்வொன்றும் இன்னொரு கார்பன் கூட it is forming a group, okay. ஒரு ஹெக்ஸகன் எடுத்துக்கோங்க, 6 சைடு ஹெக்ஸகன் எடுத்துருக்காங்க. 6 சைட்லேயுமே அந்த 6 சைட்லேயுமே என்ன இருக்குது, கார்பன் இருக்குது. அது இன்னும் அடுத்த ஹெக்ஸகன் கூட அடுத்த கார்பன் கூட ஃபார்ம் ஆகுது, புரியுதா. மேலே இருக்கிறது ஒரு சர்ஃபேஸ், கீழே இருக்கிறது ஒரு சர்ஃபேஸ், அதுக்கு கீழே இருக்கிறது ஒரு சர்ஃபேஸ். மேலே உள்ள கார்பன் நெக்ஸ்ட் கீழே வந்து ஜாயின் ஆகுது. see the lines, you are seeing the lines, no, that lines, in this method கிராஃபைட்டில் இருக்கக்கூடிய கார்பன்ஸ் இந்த மெத்தடில் ஃபார்ம் ஆச்சுன்னா that is graphite, okay. Do you understood? So it is in a hexagonal net, so sp square hybridized carbons with cc atom, carbon with carbon single bond, single bond. That அதோட bond length எவ்வளவு இருக்குன்னா 1.4 angstrom, okay, which is close to the carbon bond distance in benzene, okay. It is like benzene. So each carbon atom forms 3 sigma bonds with 3 carbon atoms, okay. 3 carbon atoms forms a bond with 3 other neighboring atoms. Understood? Using the valence electrons. 4th electron present in unhybridized orbital forms a pi bond, okay. The successive carbon sheets are held together by a weak van der Waals force. There is a force, okay. The force is held by these carbon sheets, that is called weak van der Waals force, okay. The distance between the successive sheet, okay, there are 3 sheets, no, the distance is 3.40. It is used as a lubricant or graphite oil, okay. What is lubricate? Lubricant means for lubrication purpose, okay. In vehicles also for lubricating or oil purpose, okay. So it is used as a lubricant or graphite oil. It is used in the form of graphite oil also, okay. This is the allotroph of carbon, graphite. And next, allotrophs of carbon, that is diamond, okay. Right, here the diamond is one of the best known allotrophs of carbon, okay. And it is useful for both industrial applications and jewelry, okay. In many jewelry also diamond is used, okay. Right, it is the hardest known natural mineral, okay. Now dominant industrial use in cutting, drilling, grinding, okay, and polishing. It is used in industries like என்ன purpose use பண்றாங்க, for cutting, okay, for drilling purpose, for grinding purpose, for polishing purpose, okay. This diamond is one of the best known allotrophs of carbon, okay. What you told, unlike graphite, the other allotroph diamond is very hard. This diamond is very hard, okay. It is very hard. So this carbon atoms in diamond is sp3 hybridized, but in graphite is sp2, okay. That is orbital, s orbital, p orbital. That is sp2 orbital, here sp3 orbital, okay. And the bond length is 1.54, okay. It results in a tetrahedral arrangement around each carbon atom. See the picture, there is a tetrahedral arrangement. Tetra means 4. See, there is a square shaped, okay. That is a 6 atoms. Here that is a tetrahedral form. Here is a tetrahedral form, okay. It is being a hardest element, it is used for sharpening hard tools, cutting glasses, for making boards, rock drilling, etc. Okay. Now another allotrope, okay, that is fullerene, it is also called Buckminster fullerene or usually just fullerenes or buckyballs. See, it is like a football, no, it is like a football. So it is like a football, it is named as buckyball, the structure is in a football, shape is in a football. Okay, what is the shape of diamond? You should tell that tetrahedral form. And what is the shape of graphite? It is a hexagonal net. Graphite is hexagonal, diamond is tetrahedral, and fullerene is what? Buckyball, like a football. Okay. Fullerenes are newly synthesized allotropes of carbon. Okay, it is a newly developed carbon. Okay. Unlike graphite and diamond, these allotropes are discrete molecules. Okay, these are discrete molecules. These molecules have a cage-like structure. It is like a cage-like structure. Okay, it is like a ball structure. So it is called Buckminster fullerene. It has a fused ring structure, consists of 26. Okay, 26 membered rings. Okay, in each and every member there is a 6 atom. See, 1, 2, 3, 4, 5, 6. It is also hexagon shape. So in each and every member there is a 6 member. Okay, it consists of 20 members and 12 5-membered rings. Okay, 12 5-membered rings is there and 26-membered ring is there. Okay, 5-membered ring pentagon. Okay, pentagon வந்து 12 இருக்கு, hexagon வந்து 20 இருக்கு. Okay, you understood? This is also sp2 hybridized bond. Okay, the bond distance is 1.44. Okay, these fullerenes are molecules of varying sizes. It is composed entirely of carbon, fully carbon now, okay, which form a hollow sphere, okay, or an ellipsoid like that. Okay, these fullerenes were under study of potential medicinal use. Okay, for binding the specific antibiotics to the structure to target resistant bacteria and even target certain cancer cells such as melanoma. Okay, for treating the cancer cells such as melanoma. Okay, children, these are the allotropes of carbon fullerene. Next, nanotubes. Okay, see, it is like a tube-like structure. Okay, these carbon nanotubes. It is also recently developed, okay, recently discovered, okay, not developed, discovered, okay, recent ஆ தான் கண்டுபிடிச்சிருக்காங்க. இதுவும் ஒரு கார்பனோட allotrope அப்படிங்கிறது. Okay, it is have the graphite like tubes with fullerene ends. Okay, அப்போ என்ன இருக்கு? It is like graphite and the ends are like fullerene. Okay, it is like graphite and the ends are like fullerene. Okay, so it is a combination of two, that is graphite and fullerene. Okay, so along the axis these nanotubes are stronger than steel and conduct electricity. So it conducts electricity. It is a stronger, more than steel. Steel விட this stronger. Okay, so these have many applications in nanoscale electronics. Okay, it is a field in electronics. Okay, and for catalysis. Okay, catalysis means increasing the production, like that, a reaction. Okay, and using polymers, that is plastic field, and also in medicinal field. Okay, this is the carbon nanotubes. There is another allotropic form of carbon, that is graphene. Okay, it has a single planar sheet of sp2 hybridized atom that are densely packed in a honeycomb structure. Now carbon monoxide. Okay, now we are going to see about carbon monoxide. Okay, it is a carbon family. So we are going to see about carbon monoxide, carbon dioxide, silicon tetrachloride, silicones, okay, silicates. These are the carbon groups. Okay, right. First of all, carbon monoxide prepared. How it is prepared? Okay, so carbon monoxide is prepared by the reaction with carbon with limited amount of oxygen. Okay, so on industrial scale this carbon monoxide is produced by the reaction of carbon with air. So carbon C and air is oxygen. So carbon oxygen, it will form CO, that is carbon monoxide. Okay, on the carbon monoxide formed will contain nitrogen gas also, and the mixture of nitrogen and carbon monoxide is called producer gas, okay. Now this producer gas is passed through a solution of copper chloride, okay, under the pressure, which results in the formation of CuCl CO2H2O, okay. At reduced pressure, the solution releases the pure carbon monoxide. In this way, carbon monoxide is formed, okay. And what are the properties of carbon monoxide? It is a odorless gas, okay. It is a odorless gas, it is a colorless gas, it is a tasteless gas, okay. No odor. What is odor? Means smell, okay. No smell, okay, and no color, okay. We cannot give a color to it, and it is a tasteless gas, okay. It is produced by the incomplete combustion of carbon particles, okay. Incomplete combustion, okay. Incomplete. So full combustion nadanduchina, okay. For example, in a vehicle, okay, in a vehicle while you are traveling, there is a combustion chamber, okay. In that combustion chamber, the fuel and the air intake, okay, the combustion process takes place, okay, and the smokes are released outside. If there is a complete combustion happen, then there is no release of carbon monoxide. Carbon monoxide is a harmful gas which causes pollution. So if the combustion is not proper, okay, if there is a improper combustion, incomplete combustion, some dust particles will be present, that will release, and that is called the carbon monoxide. That is called the carbon monoxide, okay. So it is produced by the incomplete combustion of carbon materials, okay. It is normally present in air at less than or equal to 10 parts per million, okay, or less. So toxicity, what is toxicity? It is a dangerous one. It begins at 100 ppm. 100 ppm. What is ppm? Parts per million, okay. It is also a endogenous substance, okay. 200 to 250 times greater affinity for hemoglobin than oxygen. 200 to 250 times greater affinity for hemoglobin than oxygen. It is a greater affinity, and reversible binding at the ion porphyrin center of hemoglobin, producing the carboxyhemoglobin, okay. It is used as a strong reducing agent, okay. In the previous classes we can see carbon monoxide is used as a reducing agent in metallurgy, okay. Under high pressure and temperature, the mixture of carbon monoxide and hydrogen gives a methanol, okay. And Fischer-Tropsch synthesis, okay. There is a process called Fischer-Tropsch synthesis, okay. In that reaction, carbon monoxide forms a numerous complex compound with transition metals, in which the transition metal is in zero oxidation state, okay. Now what are the uses of carbon monoxide? What are the uses? It is a good reducing agent. The most important thing is it is a good reducing agent, and the mixture of hydrogen and carbon monoxide, water gas, and the mixture of carbon monoxide and nitrogen, that is a producer gas, okay. Two gases is as water gas and producer gas. Water gas is carbon monoxide plus hydrogen. Producer gas is carbon monoxide plus nitrogen, okay. These are very important industrial fuel, okay. And this carbon monoxide reduce metal oxides to metal, okay. Reduce the metal oxides to metal. So calcium oxide plus carbon monoxide, okay. If it act as a reducing agent, what happens? We will get the calcium as a metal, okay. So it is a good reducing agent, and it can reduce many metal oxides. Next, carbon monoxide is an important ligand and forms carbonyl compound with transition metals, okay. Carbon monoxide is an important ligand. So it forms a carbonyl compound, okay, complex compound form agum, that is a ligand, okay. So these are about carbon monoxide. Next, what is CO2? CO2 means carbon dioxide, okay. Let me tell you about carbon dioxide, okay. Carbon dioxide, what is we breathe oxygen and we leave what? Carbon dioxide. But what trees do? Trees breathe carbon dioxide and it liberates oxygen, okay. So that carbon dioxide occurs in nature in free state. Everywhere around you, what is there? Carbon dioxide. It is in combined state. It is in free state. It is in combined state also, okay. What is combined state? Rendu moonu gas kuda kalandirukum. Free state means it is single, like that. So carbon dioxide is in free state or combined state. So it is a constituent of air, okay. It occurs in rock as calcium carbonate, magnesium carbonate, okay. In rock also, okay, that we tell no, calcium carbonate, magnesium carbonate, like that. It occurs in the form of rock, okay. Now how it is produced, okay. In industrial scale, it is produced by burning the coke. What is coke? That is carbon. Okay, carbon plus oxygen. Carbon plus oxygen. If we burn at certain heat, we will get the carbon dioxide. So carbon plus oxygen, we will get carbon dioxide. Okay, and calcination of lime. So CaCO3. CaCO3, that is calcination, and when we do the calcination, we will get CaO, calcium oxide plus carbon dioxide, and it is prepared in laboratory by the action of dilute hydrochloric acid. Okay, dilute hydrochloric acid on metal carbonates. Okay, and this properties of carbon dioxide, it is a colorless gas. We cannot see it, isn't it? It is a colorless gas. Okay, and it is a non-flammable gas, and it is heavier than air. It is heavier than air, and its critical temperature is 31 degrees Celsius. 31 degrees Celsius, and this carbon dioxide is a very stable compound, okay, and even at 3100 Kelvin, only 76% decomposes to form carbon monoxide and oxygen. At still higher temperature, it decomposes into carbon and oxygen. Okay, it has oxidizing behavior. It acts as a strong oxidizing agent, but carbon monoxide acts as a reducing agent, and carbon dioxide acts as a oxidizing agent. Okay. And what are the uses of carbon dioxide? It is used to produce inert atmosphere for chemical processing, and it is important for photosynthesis. Okay, in the process of photosynthesis, carbon dioxide plays a major role. Okay, it is also used as a fire extinguisher. Okay, during fire. Okay, in many areas, the fire service will bring the fire extinguisher. Okay, they emit a gas, that is the carbon dioxide. Okay, so it is used in fire extinguisher and as a propellant gas. Okay, in the production of carbonated beverages, okay, cool drinks like that, and the production of foam also, this carbon dioxide is used. Now silicon tetrachloride. Okay, silicon tetrachloride can be prepared by passing dry chlorine over an intimate mixture of silica and carba. Okay, silica எடுத்துக்கோங்க, carbon எடுத்துக்கோங்க, you are heating at 1675 Kelvin and you will get the silicon tetrachloride, SiCl4. Okay, you can see the equations in your book. Okay, now what are the properties? It is a colorless liquid. Okay, it is not a gas, it is a colorless liquid. Okay, it freezes at minus 70 degrees Celsius. It freezes. Okay, it becomes solid. Okay, so in moist air, the silicon tetrachloride is hydrolyzed with water to give silica and hydrochloric acid. Okay, all the equation you do it as a homework. Okay, each and every day you go through it. Okay, right. And what is alcoholysis? The chloride ion in silicon tetrachloride can be substituted by a nucleophile that alcoholysis. Silicon tetrachloride reacts with alcohol and it forms a tetraethoxysilane. Okay, and there another process, ammonia lysis. Okay, the silicon tetrachloride reacts with ammonia. Okay, and forms a chlorosilanes. Okay, you see the equations in page number 46. Okay, and the silicon is used in the production of semiconducting silicon. Okay, production of semiconducting silicon. It is used as a starting material. In the synthesis of silica gel. Okay, binding the ceramic materials, silicic esters, like that it is used. Now silicons. Okay, now silicons are also called polysiloxanes. Okay, Okay, what is silicon? It is based upon the similarity of organosilicon compounds. Okay, with ketones. Okay, these are see the picture, the siloxane, polydimethyl siloxane. This is the structure of siloxane. Okay, and the silicate resin, see, one silicon atom, one oxygen, like that it forms a cuboid structure, that is the silicate resin. Okay, it is in this structure. Okay, it is prepared by the hydrolysis of dialkyl dichlorosilanes. Okay, it is used in this preparation, right? And there are types of silicons: linear silicons, cyclic silicons, cross-linked silicons, like that there are different types of silicons. Okay, and what are linear silicons? They are obtained by the hydrolysis and subsequent condensation Okay, hydrolysis and condensation. Okay, hydrolysis means reaction with water. Okay, H2O. So linear silicon is obtained by the hydrolysis, and cyclic silicons are obtained by the hydrolysis of SiCl2, silicon chloride, and cross-linked silicons are obtained by the hydrolysis of SiCl3. Okay, and the linear silicons are further classified into silicon rubbers and silicon resins. Okay, in silicon rubbers, the silicons are bridged together by methylene, and the silicon resins, they are obtained by blending silicons with organic resins. And what are the properties? Okay, it is the oily liquids to rubber like solids. It is converted from oily liquids to rubber like solids. Okay, all silicons are water repellent. Okay, water repellent. This property arises due to the presence of organic side groups that surrounds the silicon, which makes the molecules look like an alkene. Okay, right. And what are the uses of silicons? Silicons are used for low temperature lubrication and in vacuum pumps. Silicons are used for low temperature lubrication and used in vacuum pumps, high temperature oil baths, etc. They are used for making waterproofing cloths. Okay, and they are used as an insulating material in electric motor. Electric motor la silicons vandu or insulator ah work agudhu. Okay va, and used for making waterproofing cloth. Okay, they are mixed with paints and enamels to make them resistant towards high temperature sunlight, dampness and chemicals. Okay, with paints and enamels also silicons are used. And silicates. Okay, silicon forms a strong bond with oxygen, that is silicate. Silicon plus oxygen gives silicates, that's all. Silicon plus oxygen, that gives the silicates. Silicon forms a class compound with oxygen, that is called the silicates. So basic unit in all the silicates is the tetrahedral ion. Basic unit in all silicates is the tetrahedral ion. See, the structural formula is given and the ball and stick model is also given. Okay, the mineral which contains silicon and oxygen in a tetrahedral unit. Okay, linked together in different patterns. Okay, are called silicates. Nearly 95% of the earth crust is composed of silicate minerals and silica. Now the glass and ceramic industries are based on the chemistry silicates. Okay, now what are the types of silicates? Orthosilicates, pyrosilicates, cyclic silicates, inosilicates, chain silicates, double chain silicates. Okay, there are various types of silicates are given. Okay, various types of silicates and their structures are given. Okay, it is based upon the structure only. Okay, it is in a tetrahedral form. Okay, double chain silicates is there. Okay, in this silicates it contains ions. Okay, ions of different tetrahedral shapes. Okay, with 3 vertices sharing only 2 vertices, like that. Okay, these are the various types of silicates. See, the types of silicates are orthosilicates, pyrosilicates. Okay, what is orthosilicate? It is the simplest silicate which contains discrete tetrahedral units. It is a simple silicate. Okay, the examples are phenacite. Okay, phenacite, olivine. Okay, these are the some examples ions. Okay, what is pyrosilicate? Which contains ions. Silicates which contain ions are called pyrosilicates. Okay, they are formed by joining 2 tetrahedral units by sharing 1 oxygen atom at corner. Okay, 1 oxygen atom வச்சு 2 பேர் ஷேர் பண்ணுவாங்க, that is pyrosilicate. And what is sheet silicate? Okay, that is a chain silicate that contains n number of silicate units. Okay, n number of silicate unit. Okay, in sheet silicates that is also called phyllosilicates. Okay, each tetrahedral unit shares 3 oxygen atom. Okay, ஒவ்வொரு silicates லையும் என்ன எத்தனை oxygen atom ஷேர் பண்ணுது, 3 or 4 or 2 or like that. Asbestos is also an example for double chain silicate. Okay, these are fibrous and non-combustible silicates. Okay, therefore they are used for thermal insulation material, brake lining, construction material, filters. Okay, asbestos is an example for double chain silicates. Okay, double chain silicate, single chain silicate, ring silicates, that is called cyclic silicates. Okay, different types of silicates based upon the sharing of 1 oxygen atom, 2 oxygen atom, 3 oxygen atom, like that. Okay, it will be the silicates are used as a asbestos sheet. Okay, in many houses you can see asbestos sheet. Okay, these are made up of silicates. Okay, you understood? Now what is zeolite? Okay, zeolite are a 3-dimensional crystalline solids. Zeolites are three-dimensional crystalline solids, okay, that contains aluminium, silicon and oxygen in their regular three-dimensional framework, okay. Now they are hydrated sodium aluminum silicates, okay, with certain formula. Okay, the zeolites have a porous structure, okay, porous structure in which the monovalent sodium ions and water molecules are loosely held, okay. Now the silicate ions and aluminum atoms, okay, the tetrahedrally coordinated, see in the picture they are tetrahedrally coordinated with each other through a sharing the oxygen atom. Here also oxygen is shared, okay. The primary building unit of zeolites are cation coordinated by oxygen in a tetrahedral structure, okay. Tetrahedral structure, it is having a three-dimensional crystalline structure, looks like a honeycomb consisting of a network of interconnected tunnels and cages, okay. Do you understood? Okay, these are the zeolites, these are zeolite, okay. That's all, this unit is completed, okay. Next class we will see the unit 3, okay. Now today we have seen about the group 14 element, the group of carbon, okay. Structure eppadi irukku, endha atoms enga join agudhu and the equations and everything, okay. These are about group 14 elements, okay children. Do you understand children? This lesson is full of P block elements, go through it, okay. Each and every topic you go through it and study well, okay children. Concentrate on your studies, stay home and stay safe, okay. Now we are going to see the homework. Right, write down any 10 one words, okay, any 10 one words from the topic, okay. Group 14 elements, page number 40, page number 40 to the end, okay, for 51, 40 to 51, okay. Write any 10 one words and the structure of carbon dioxide and structure of carbon monoxide, okay. Go through it, okay. Carbon monoxide oda preparation eludhanum, adoda properties eludhanum, okay. Preparation, properties, okay, and the process what is done there, okay. Write the equations and everything in your classwork note. Carbon dioxide and carbon monoxide oda preparation, properties, okay, and their structure, okay. Right, and the Fischer என்ன ப்ராசஸ் இருக்குது, சில இதில் ஃபிஷர் ட்ராப்ஸ் சிந்தசிஸ் ப்ராசஸ் இருக்கும், சில இதில் வந்து ஆல்கோஹாலைசிஸ் அண்ட் அனிமோலைசிஸ் லைக் தட், ஓகே. அந்த ப்ராசஸ் எல்லாமே, ஓகே. கார்பன் மோனாக்சைடை பற்றி ஹெட்டிங் என்னெல்லாம் இருக்குதோ எல்லாம் எழுதி அந்த ஈக்குவேஷன்ஸை பக்காவாக எழுதி கிளாஸ் ஒர்க் நோட்டில் வச்சுருங்க, ஓகேவா. ரைட், அண்ட் in your homework you write 10 one words, okay, and your assignment is you have to write the uses of silicons, uses of carbon dioxide, uses of carbon monoxide, uses of silicon tetrachloride, okay. Any 2 to 3 points will be there in your book, study well and write it as a assignment, okay. And second question, that is zeolite, and zeolite is also your assignment, okay. The first question, carbon dioxide and carbon monoxide, you have to write it in your classwork note, okay. Carbon dioxide and carbon monoxide, you have to write it in your classwork note, and the 10 one words you have to write it in your homework note, and the uses of silicons, carbon monoxide, carbon dioxide, silicon tetrachloride, okay, and the zeolites, okay, about zeolites. These all things you have to study well and write it as assignment, okay children. That's all, these are your homework. Thank you children, have a nice day.